It's a presentation of what he gave last week at OSCon. For those of you who don't know Jonathan, he's the current president of Linux Australia. He's authored Ubuntu hacks and how to build a website and stay sane. Debian developer, organised a bunch of Debian mini comps for the last 5 years or something. Generally all-round good guy. And he's got a RFID chip in his hand for extra cred. So please welcome Jonathan.
Great. Thanks, Andrew. So I assume just about everybody in the room is a software developer or a system administrator, something like that. Okay. So you work in software. Well, basically what that means is most of the time all you're doing is pushing bits around. Ultimately, that's what it is. Well, in the world of software, we change pixels on screen. Maybe we make a bit of sound, and it's not really all that exciting. So what I'm here to do today is to free your mind, basically to show you how to take the skills that you already have in software development, system administration, and generally playing around with computers. And then, the skills you've got in bits and pixels and things like that, and use those skills to reimagine reality, and not just virtual reality, which is what exists inside our computers, but physical reality as well. The actual stuff that is all around us. And there is a warning though. Once you get out of the realm of the computer, there are some things you have to be careful of. Some of the stuff I'm going to show you today, if you're not careful with it, can actually do nasty things to your actual physical body, not just to memory in your computer. So I accept no responsibility. I'm hoping that you'll all go away and try lots of really cool things out of this, and that you will take some of the ideas and maybe little snippets of the techniques and apply them to other things that I haven't thought of. And I'd love to hear about it afterwards, but basically I take no responsibility. So how do you get out of the realm of software and into the real world? Well, there are a whole bunch of ways that you can connect to your computer. Computers have got a lot of different ports on them. There's parallel ports, serial ports of various flavors. If you want to get really hardcore, you can even actually build your own PCI cards and various things like that. For a software developer, it sounds like that's a really way out thing to do, but it's actually not really that hard. There are prototyping kits you can get that will help you to build PCI cards that you can then talk to directly. If you're just starting with this, one good thing to get started with is a parallel port. Basically because it's dumb. It's a really, really simple port. It's got no flow control, no comms protocol, nothing you have to worry about. Basically, all you have to do is worry about flipping bits, and we already know how to do that. If you look at an actual parallel port, it is simply a representation of bytes of memory space actually out into the physical world. Now those blue pins across the top are the data pins, and there are 8 of them. It's a byte. So a parallel port basically occupies 3 bytes of memory space, and we can talk to it just by twiddling memory, which makes it really easy to deal with. So either control stuff pushing data out of the computer into the real world, or detecting events and reading them in. But the thing is, the parallel port is bad because it's dumb as well. You've only got those bits to play with. There's not a whole lot you can do with it. You can put extra parallel ports in your computer, but that's a pretty silly way to go. It also doesn't have any sense of analog input or output. It's just bits, and that's it. So there are some better ways to connect to the computer, which we'll get to in just a moment. And the other thing is that scripting language support is very poor for parallel ports. If you're wanting to play around with little bits of glue code in Perl or Python or whatever, it can be quite hard to get access to the serial port or the parallel port directly. But you can use a trivial C helper if you want to do it that way. So what we'll do is have a quick look at how easy that is to do. Now up here I have a little device which is basically 8 monster LEDs connected to the bits on the parallel port, and it's a trivial circuit. Unfortunately, it's going to be a little bit hard to see, but I did use the biggest LEDs I could find. Now let's have a look at how easy it is to connect to the parallel port and either read in from it or write out to it. Now if we have a look at a tiny little piece of code, basically all we need to do is load a couple of libraries which gives us access to I/O and various things like that, and then we're defining the actual location in memory that we're going to be dealing with. So a parallel port exists at hex value 378 generally, unless you've got multiple ports or it's an odd architecture or something like that. And then it starts at that, and then it's the next couple of bytes after that as well. So In this particular case, all we're doing is taking a value that is passed into the program as an argument, and we're down the bottom you'll see it's got an outb or outbyte command. Basically that's just pushing that byte of data at the parallel port. Very easy. And all you do is, let's do some, we'll do a bit of a test here. LPT out.c. We'll see if we can actually make it do it. Okay, so we'll give it a value of say 255. Aha, need sudo to get access to the parallel port. And of course I can't type my password. That's better. Yay, we got something. Okay, cool. So we could arbitrarily turn different bits on that port on or off simply by sending different values to that little script. So that makes it really easy to control, say, up to 8 discrete devices. We could just connect relays in place, and then we could turn stuff on and off, which is pretty cool. And you can also read from the parallel port just as easily. In fact, it's even easier. All you do is set permissions to give yourself read privileges from the port, and you suck in a byte from the port. Now, in this case, you'll notice that we've gone for the address of port address +1. So that's the second byte of the port. In this case, that's the input data. And then we're just echoing it out. So I won't show you that one live, but I've got a, just to show how simple it is, I've got a little circuit here which is just some buttons that assert the lines on the parallel port. And that program, when you run it, will detect which buttons have been pressed. So it makes it very easy to connect to anything which is something like a switch or a switch-like device. Which raises another thing. When you start looking at the physical world and what you can connect to, just about everything represents itself as a switch in terms of an input. If you want to connect to a motion detector, for example, it's just a switch. If you want to measure, angle or tilt or pressure or something like that, most of the time they represent themselves as a switch. So it makes it really easy to detect events and acquire data and then pull it into the world of software. Once you've got it into the world of software, then we're in the environment that we're all comfortable with and we can do things with it. We can make decisions on the basis of the data that's been pulled into the system. But as I said, the parallel port is very limited. It's good if you want to just get started because you almost need nothing at all, just a couple of components. Go down to Radio Shack and $1 will have you all the parts you need pretty much. But it's limited. So if you want to take it a bit further, one of the things you can do is use an Arduino board. And there are a number of other prototyping boards around. Now, it's probably easier to see up there. I've got one right here as well. An Arduino board is a little microcontroller board. This is actually open source both in terms of the hardware and software. It was developed by a couple of Italian designers and is based on an Atmel microprocessor. So you can go and buy these pre-built for about US $30, something like that. It's got a bunch of digital I/O lines on it. And the actual designs themselves are open source. So you can download the circuit board layouts, you can manufacture these yourself and sell them if you want to. It's under a really liberal license. And there have been something like 10,000 of these boards sold now. So they're used in all sorts of applications all around the world. They come in a few different types. You'll see up there in the top left is the USB version, which is what I've got right here. There's also a Bluetooth version in the top right, and there is a mini version, which is basically the same thing, but without all the convenient connectors on it. So it's been compressed down to a very small board, and as you can see, it's got a quarter next to it to show how small it is, so they're really tiny. But they still have all of the I/O lines and things like that. So if you're doing prototyping, these are a really cool board to use. What you can do is do your development on one of the USB or Bluetooth boards, and then when you're happy with that everything's working, transfer your program over into a mini and it will just run. Now these things are really simple. You write the program in an IDE, which once again is free, and actually let's have a look at that. So this is an IDE for this particular board. It's basically a development of processing. How many people here have heard of the script decoding system called processing? Yeah, a couple have. Okay, cool. Which is in turn based on wiring. It's a system for very rapidly developing code to represent real-world objects and things like that. So essentially, this is a hardware representation of the program. And also, I should point out that if anybody's got comments and questions and things along the way, just throw them out. I'm going to sort of just roll through this pretty fast, but I'm sure there are a bunch of people here who have done very similar things. So if you've got comments, suggestions, then yes?
There is a GCC port for Atmel 8-bit microcontroller, so you can do it on GCC as well.
Yeah, the comment was that there is a GCC, you can compile for using GCC for this. And in fact, that's what this Arduino IDE uses. In the back end, it actually relies on GCC. So it then cross-compiles for the Atmel architecture when you tell it to do it. And in fact, let's see how easy it is. What we're looking at there is a program. It's just got a loop in it. It does a couple of things that we'll get back to later. I won't explain that in detail right now. But basically, all you need to do is hit the little verify button, which is what they call compile. And it's told us that it's created a binary sketch down the bottom, so it's actually built that, it's cross-compiled that software. And then to send it to the board, all I'll do is plug it into the USB port, so it powers up. Now when the board first powers up, it spends about the first 6 seconds, I think it is, looking for a device to talk to it. And if it finds it and negotiates a connection, it will then grab whatever program is available. It's basically like a Pixie boot sort of system. So it'll grab whatever is available, load it, start executing it, and it will just run it forever. Anytime you reset the board, it just starts up again, and it's all held in non-volatile memory. So what we can do to get that program onto the board is just press the reset button on it, which I'll do now, press upload. Down the bottom it says uploading to I/O board. And if it finds it successfully, yep, it's reported firmware version 1.15. So it's found the board, it's uploaded the program, and the board itself is now leeching power off the USB connection. So it will now be running that program just forever. If I unplug it, it'll stop, plug it back in. It goes through its power-up cycle, looks for a new program. If it doesn't find one, it just starts running it again. And you can run these off a battery as well. They're extremely low power. So you can just plug in a 9-volt cell or something like that. And you don't even need the computer connected. It becomes a standalone device at that point. So those are really cool little devices for playing around with. So let's have a look at some of the things you can do. If you've got some building blocks that allow you to acquire data into the world of software, or push control signals out into the physical world, what are some of the things you can do? Now, when I'm doing talks about hardware hacking, what I normally do is use my front gate as my example of real-world things you can hack. Most people think, what the hell can you do with a front gate? But the reality is that my front gate's probably got more processing power in it than most people's offices, including dual gigabit Ethernet and quite a few other things. So let's zoom in a little bit on this picture, in towards the left. You see the letterbox. Now, going to check whether there's any mail in your letterbox is a pain. Basically, a letterbox is a polled interface. You have to go and keep polling it to see if there's anything in it. Wouldn't it be good if you turned it into an interrupt-driven interface instead? Well, you can. What you can do is use something like a read switch. In my particular case, on the back of the door is a little magnetic switch which detects when the door has been opened. And just to simulate this, in the longer talk that I did at OSCON last week, I brought along this box. And so this is a representation of my letterbox, and it's got the read switch and everything wired into here, which actually reminds me of something. I think I just set a personal record for the weirdest stuff or the most suspicious stuff I managed to get through US Customs. So I arrived in the country with a box wired with a read switch, with obviously hand-soldered electronics sitting inside it, and some various other things that we'll get to in just a moment. So what you can do is detect the fact that the letterbox has been opened, and then trigger some event, which could be sending an SMS saying, hey, you got mail in your letterbox, go and get it. Or sending you an email, or linking into Second Life or some other virtual environment and showing the status of your physical letterbox inside the world of software. Similarly, on the gate itself, there is a read switch. That's just in the actual frame of the gate, so it detects if the gate has been opened. And then you can have the computer aware that someone has just entered the property. In terms of output, there's a light up underneath it, so you can turn that on in certain situations, like you can tell it to only turn on if someone enters the property and it's dark. Other things you can do. Okay, magnets. That is a big electromagnet. Basically, it's a door lock. So that is on the door of my office back in Melbourne, Australia. And because it's an electric lock, it means that it can be computer controlled. Once again, we can pull the physical world into the world of software. Now, those things are ridiculously expensive, but if you go down to local hardware store, you can get something like this. This is an electric striker plate. Now, in Australian dollars, these are about $40, so like 30 bucks US. And all you do is mount this in the actual door frame so that the door catch hooks into the back of it instead of the little static metal plate, which is normally installed. And by applying 12 volts to it, it releases. Dead easy. So all you need to do is fire a relay or something, and you can unlock a door electronically, which brings it back once again into the realm of software, and you can control that from software. Now, on that same door back in Melbourne, there is one of these little devices. So who wants to guess what that is? Nobody does. Okay, well, that is an RFID reader. And this just goes to show that there are a lot of devices that you would probably think are hard to interface with. You might think they're fairly esoteric. They might have unusual communications protocols or something like that. A lot of the time they don't. In this particular case, well, what I have right here is a homemade RFID reader. I actually had a lot of trouble putting this one together because most of the chipsets that are available are for the US standard 125 kilohertz RFID tags, and in Australia we follow the ISO standard, which is 134.2. So in the end I had to basically build the whole reader myself. I couldn't use many off-the-shelf components. So it's got a hand-wound coil in there and everything. But it's got a USB interface on it, so when you plug it into a computer, it simply enumerates itself as a serial device. And then you can talk to it directly through a serial port. Now, once again, a serial port is not something that you can trivially talk to from a scripting language. Although about a year ago or so, one of my staff actually wrote an entire serial port driver natively in PHP, which is an interesting exercise. But it worked. It showed he was insane, but it worked. But there are much easier ways around that. There's a really cool little utility called SER2net, or SER2, the number 2 net. And what that does is take any serial port on your computer and expose it as a network socket. Now that opens up some really interesting possibilities, because one thing that's really, really easy to do in pretty much any scripting language is talk to a network socket. So let's have a look at that. We'll unplug the old Arduino that we had a second ago. We'll plug this in. And we'll have a look at the config file for SER2net. Now, it might be a little bit hard to read, but down the bottom there is an entry which says, I want to map TCP port 2000, expose it as a telnet protocol, and I want to link that to dev TTY USB 0. So whatever physical device appears on TTY USB 0, expose it as a network socket. And there is some configuration there that tells it what speed the serial device is going to be, whether it's got stop bits, all of that sort of thing. But it's pretty easy. So what we have now is a serial device exposed as a network socket, which makes it very easy to talk to. So we could have a look at, and in just about any language, any scripting language, it's trivial to open a network socket. So let's just have a quick look at that one. Okay, so it's found the device. The device itself has identified itself. Well, SER2net has identified itself. And just to make things interesting, what I have here is an implanter for an implantable RFID tag, it's probably going to be rather hard to see because it's about the size of a grain of rice. But here we have an implantable RFID tag. So this is what would typically be put inside, a dog or a cat or something like that, so that it can be found and returned to its owner. The RFID tag itself contains a unique serial number, so whenever it's scanned, it will just return that number. The tags themselves are passive, so there's no battery or anything in it. It's simply powered up by induction caused by being put into a field. So if we take that near it, you can see that it's just read the tag. So we're reading an implantable RFID tag using PHP in this case. And it's just as easy to, well, this is the old school way of doing it. Larry Wall actually saw a talk I did where I showed this code and he laughed at me. But nowadays you would do it with a CPAN module that gives you access to doing this. But that's still pretty simple. Or we can do it in Python, once again, dead easy to open a network socket. And just for the fun of it, you can even do it in TCL. So here we are reading an implantable tag in TCL with only a couple of lines of code and one little helper script. So doing this sort of stuff is a lot simpler than you might first think. Once you start seeing a few of these little building blocks like SIA to net to expose serial ports, it makes it really easy to start linking into it in whatever environment you might want to work in. So it really doesn't matter what your preferred software environment is. This sort of stuff makes it really easy. Okay, other things you can control. Curtains for lazy people. Now, a little while ago, my wife and I had our kids' bedrooms redone. So we had replastered and all of that sort of stuff. And when we got prices on curtains, I just about had a heart attack. I mean, how many people here have replaced curtains in their house? Only a couple. Okay, well, for those of you that haven't, be glad you haven't because it's really scary. There were a few more zeros on the price. I was thinking, it's a bit of material. It hangs from the ceiling. How much can it cost? And it was a lot. And then once I got over that shock, I started thinking, it'd be really cool if we could remote control them. And I started looking for commercial controllers. It turns out that the cost of an electric curtain track is relatively high. Like it's in the order of hundreds of dollars. But in the overall scheme of things, if you're doing new curtains or new drapes, that's actually a pretty small percentage of the cost. So we ended up putting in commercial electric curtain tracks. So what you can see there just to the left of the curtain track is the controller that goes on the wall. Now, this particular curtain track that we got is not intended to be networked. It's basically a dumb device. There's an infrared remote control that comes with it and some little buttons on the box on the wall, but that's it. It's not meant to be linked into a home automation system or a computer or some Frankenstein's monster device that I typically concoct. But this is an example of a really important point, which is that just about anything which has buttons, you can control by ripping the box off and wiring a relay or something across the buttons. You can control the relay from your computer. You can control the device. So this is just another view of the same thing. There's a little barrel motor sitting and a really, really long thread that goes down the middle of the track. So now we have curtains that can be controlled from the computer, which raises some interesting possibilities like being woken in the morning by sunlight coming into your room instead of an alarm clock blaring. And I don't have a slide for it, but a similar project I've got in the works at the moment is a computer-controlled skylight cover so that we can open and close the skylight baffles. So in the morning, the room can go from dark to light. Another device, and some people say this is going too far, but anyway, many years ago, my job actually used to involve using barcode scanners. So I've got a few spare ones at home. And this is a laser barcode scanner. Barcode scanners themselves are another one of those devices you would think are esoteric. They're hard to drive. But most of them simply pretend to be keyboards. So you plug them into a keyboard port. In this particular case, it's a really old one that plugs into an early Mac. So that one's plugged into a Macintosh LC475 or some super power beast like that. And it just acts as if you've typed directly onto a keyboard. So when you zap a barcode with it, it simply sends the stream of characters back as if you'd sat there and typed the number in yourself, which makes it really, really easy to link it into things. So in this particular case, a web browser sitting on with focus on an input button, so that when you zap something, it simply types the code into this little form, and then after it's finished sending the code, it sends carriage return, which is as if you'd pressed enter on your browser, and you've got a form submission simply by zapping a barcode. And once you've got that, all sorts of things are open to you. Now, this is the project that really got me started on this whole kick of modifying typical everyday objects. In Australia, in Victoria, we've had a drought for about the last 8 years. We've had some really harsh water restrictions. And just keeping plants alive is a real problem. So a couple of years ago, what I did was started looking around at putting in drip feed sprinkler systems and things like that. And went down to the hardware shop, and the computerized smart controllers were ridiculously expensive. They were many hundreds of dollars for basically something that was just a glorified timer. And I thought, I can do something a whole lot better than that. So what I did was bought the cheapest electronic timer tap that I could find. So this is a little garden mate thing that would sell for about $15 US or something like that. Inside, all it is a little timer that drives a motor. So once again, I ripped it open. On the bottom, you can see there's a little RCA connector. Internally, that goes to a little thing that bypasses the timer and simply tells the motor to switch to the on position. So, a screwdriver and 10 or 15 minutes of modification, and we've got a timer that we can control out of the computer. So then we've got all sorts of possibilities open to us. So that brings us to how this all ties into Second Life. What I've been talking about so far are ways to take the real world, link it into software. But that's not where it has to end. It's not just a matter of controlling things from the command line or putting a GUI interface on it. What you can do is, once you've got events into the world of software, link that all the way through to an environment like Second Life. So how many people here have used Second Life? Okay, quite a few haven't. Well, let's go to Second Life. You're about to be logged off for an activity, great. Oh, well, I'm not. So for those of you that haven't seen it, this is Second Life. Looks a lot like a 3D first-person shooter. Basically, it's a shared virtual reality environment that you can go into and move around. Not all that revolutionary in itself, but there are a few things that make this really interesting. One is that in a typical game-type environment, like a standard first-person shooter, or just about any virtual reality environment, there is going to be some form of scripting within it. So objects are scriptable. If you've played any first-person shooter, then you would know that objects can react when you shoot them and things like that. You touch a door and it opens. The thing is that scripting layer is normally hidden away from the typical end user. So as a user, you can interact with it, but there's not much else you can do. To really modify the world, you have to go fairly deep in under the covers and start modifying things. The thing that's really cool about Second Life is that they've exposed all of that as much as possible. And what they've tried to do is build a platform that provides you with the toolkit, basically the canvas to paint on, but then it's up to you to do what you want with it. So if you want to do custom development, you want to create scriptable objects and things that interact, you don't need anything special. If you're inside the Second Life viewer, you've got everything you need. And it's just a click away. So all we do is right-click and we go create, and we get ourselves a little creation wand. And up on the top left, you can see there's a bunch of polygons, so you can select what object shape you want. And in this particular case, let's just make a box. So we'll just click there, we've made a box. And from here, we can do things like rotate, we can resize, and you can do all the sorts of things that you would normally do in a 3D authoring type environment, but just directly in world. So you don't have to step out, make things and bring them back in again. You don't need any extra software. The other thing is that everything is scriptable. So in this particular case, we can select this again and go new script. and there is now a script that is attached to this object. Now, there are a couple of interesting things about Linden scripting language, which make it a little bit different to other stuff that you might have seen before. The first is that the whole concept of the scripting environment is based on a state machine. Now, a state machine is something that in other programming languages, you normally have to create yourself. You have to keep track of what state you're in and what is going to push you into different states and various things like that. The entire concept of Linden scripting language is that the script is a state machine. Basically, you can't get out of it. You have to have a state. When you create the basic Hello World or Hello Avatar program, it creates a single state, which is just default. State machines are really cool if you want to try to create objects that interact with you in some way or interact with other objects in a similar way to the way the real world works. Because if you think about devices like a desk lamp over there or something like that, it's got a state of on or it's got a state of off. Just about everything has various states, and then depending on what state it's in, it'll behave differently depending on what other inputs take place. And Linden scripting language is totally focused around that concept. So everything is done on the basis of states. And then triggers or events. So you can't actually define your own events. They're predefined within the system, but there are a lot of them. And you can define your own event handlers. So a really good example would be a touch start event, which is when an avatar walks up to an object and clicks on it, so they've started to touch it. What you can do is have a touch start event handler that then calls off into some other part of your program. So you can have an object which reacts to different things. It might react in one way to being touched. It might react in another way to being used in a different way. Or, for example, if you talk to it, it can react in a different way. So if we have a look at this little Hello Avatar entry back in here, what you can see in there is it's got the default state. It's got an event handler of state entry. So when it goes into the default state, the state entry handler is called and it says, hello avatar. So that's basically the equivalent of hello world in Linden scripting language. And then it has one other event handler. So if it's in the default state and a touch start event occurs, then it does ll say touched. So very easy. So it's just like echo touched or print touched. And if we close this off now and then touch this, it says, it's got the name is object and it says touched. So it's reacted to what we've done. Now Linden scripting language itself is can be a little bit hard to get your head around the first time because it's so intricately it's so intimately wrapped up in the concept of being a state machine. Everything is happening within a state machine. But once you start working with it, you realize how cool that is when you're trying to code in a virtual environment. So once again, though, that is happening within the virtual world. So these are events that are taking place within Second Life. So the question is, how do you get data in and out of Second Life? Once again, how do you breach that barrier so that you can start linking things together? LSL itself provides a whole bunch of mechanisms, and the environment that it runs in provides mechanisms. So at the moment, Second Life runs on approximately 4,000 servers. So by your guys' standards, that's trivial. But it's a reasonably significant network by any other standard. On about 12.5 CPU cores, I think they're running as of last week. So what happens is that the world or the environment that you interact with is broken up into regions. And basically, there is a sim which maintains a certain region of space or a certain physical area, and that it runs all of the scripts, all of the objects and things within it. So the way they scaled it out is that they have a grid or a mesh of all of these sims. And each one has sims on its boundary, obviously, and you can move between them. So if you're in world, you can seamlessly walk. So you can start at one corner of the universe and walk to the other corner of the universe if you want to, and you could pass across 1,000 sims and it would be seamless. You're just moving from one sim to the next. And then each of those sims provides a whole lot of extra runtime information and environmental information to scripts that are running within it. So one trivial thing you can do is email out of Second Life. So inside Linden scripting language, you can simply send an email, very easy. And you can also email into Second Life. What this means is that you can interact with in-world objects using email. If you wanted to have if you had a low priority event in the physical world, for example, and you wanted to cause some state change within Second Life, you could send an email to the object. Every single object in Second Life has an ID, which is basically like a long character string. And when you create an object, which is called resing, or bringing into resolution, the opposite of derez, an object is automatically given an ID. So every single object in world has a unique ID. And it automatically gets an email address. So that object that I just created now has an email address, which is just the ID at lsl.secondlife.com. So it makes it really easy to address it. You can also do XMLRPC into Second Life. Now this is where things start to get quite interesting. The Second Life grid itself has a gateway that we can make XMLRPC calls to, and we can send requests to specific objects. Within the object itself, you can then have an event handler that detects the incoming XMLRPC request, handles it, and then sends a response back. So once you get to that sort of level, you're getting to the point where you have a reasonable latency. With email, obviously, you might have fairly high latency, and you also have no guarantee of delivery. With XMLRPC, at least you can check on your end whether anything has come back within a reasonable time. And the response will usually take, in the order of milliseconds rather than however long an email happens to thread its way through various steps out on the internet. So let's have a look at how we can do XMLRPC into Second Life, just for the fun of it. Okay, so I was going to sleep. Okay, what we'll do is get rid of this. And I'll have a look in my inventory. Here's one I prepared earlier. And we'll pull out an object. Now this particular object, we'll go over and examine it and see what's actually in the script associated with this. So we'll just go to Edit, and we'll have a look inside the script. Now this is a script for an extremely primitive door. What it will do is have physical presence if it's locked, and have no physical presence if it's unlocked. And what it does is starts by saying, hey, this is me, and giving its identifier. Because if we're wanting to talk to this object from outside the world, we need to know what its ID is so that we can address it. And what it then does is go into a state where where remote data coming in from an XMLRPC request can cause it to change into an unlocked state. It then sleeps for 5 seconds and then locks itself again. So the summary is, in its default state, it's red, it's a wall, you can't walk through it. If a certain XMLRPC request gets to it, it goes, hey, I've just been told to unlock. It then turns green and it puts itself into a phantom state. So you can see it's there, but you can walk through it. Now, if you're actually going to do a door in Second Life, you'd do something prettier than this, but at least this is obvious and you can see it when it's up on the screen and 30 feet away from you. So let's just have a look at this. Nope, what I'll need to do is reset this. Okay, so I've reset the object. This is basically like hitting the reset button on the script. And what that's done is forced it to reinitialize the script associated with the object. One of the first things the script did was say, hey, I'm awake and this is my ID. But it set it basically as a chat so that I could see it. What we'll do is go back into chat history. It might be a little bit hard to read, but what it's saying there is ready to receive requests on channel, and it's given me an ID. So I'll copy that ID. So we can now address that using XMLRPC. So let's have a look at how we can talk to that. Okay, so what we have here is a little bit of code which reads from the serial port. So what it does is opens the local socket once again. So this is using SIA to net, which is the setup that we had earlier with the RFID reader, which is currently still plugged in. What it does is sits there and watches the serial connection, or in the socket, which is representing the serial connection. And if it detects a tag being scanned, which has a certain SHA-1 hash, it says, hey, I'm meant to go into an unlock state. And then a little bit further down, what it does is prepares some XML. So this is the actual body of the XMLRPC request that's going to be shipped off to that door in Second Life in just a moment to tell it to unlock. So what we'll do up here is we'll stick in the channel, which we just extracted out of that object earlier. So when it connects to the gateway, the XMLRPC gateway on the Second Life grid, it'll identify it and say, I want to talk to that object over there, and here's its identifier. So Second Life now knows what we're talking about. Oh, too used to being in Vim. No, colon Q does not get you out of gedit. Okay, now we'll move this over to here so we can see what's going on. Now, if you are silly enough to have an RFID tag in your arm, and we just unlock the door by scanning my arm. So at that point, I should be able to walk through it. Oh, except it's relocked. So if I walk up to it while it's locked, I can't get through it. But if I now scan my arm, it says unlocking, XMLRPC request goes through, and we can now walk through the door. So we've got semi-real-time control of the door in Second Life from the RFID reader, which is just connected to my local computer here, which is kind of cool.
What happens if you stay inside the door?
Then you can get trapped. Yeah. But it's not fatal because you can always just teleport anywhere you like. That's the good thing about a virtual world. If matter condenses around you, it really doesn't matter. Okay. So there are other ways that we can link into Second Life as well. Another way to do it is with a modified Second Life client. Now, if you're doing real-time interactivity, or you've got a lot of data that you need to get in and out, doing something like an XMLRPC request is going to be a real pain. It's faster than email, but it's still got a fair bit of latency, and there's this monstrous XML blob that you're sending to give it, one integer value. Great, thanks XML. But there are better ways you can do it. One is with a modified Second Life client. Now, if you look at the at the moment when I'm logged into Second Life, I have a client running on my local computer, which obviously is very latency critical. You need to get information back to your computer as fast as possible when someone walks into your field of view or when actions occur. And so there is a lot of data flowing backwards and forwards between the client and the environment. Now, one clever way that you can get a lot of data either in or out of the environment is by running a modified client. And the actual Second Life client itself has been open sourced. So one of the very first hacks that was done after the client was open source, I think this was about 3 days later, was a friend of mine, a British developer named Matt Bedolf, did a little hack using one of these Arduino boards. What he did was connect a variable resistor to one of the inputs, to the analog input, and set up a program that sent the value from the Arduino board into a modified version of the Second Life client. So if we have a quick look at this video, what he's doing in this case is sending that value into Second Life through the client, which is then chatting to the object. So what he's got is an object which moves up and down on the basis of the altitude that it's been told to go to. So on the left, we've got the little Arduino board with the variable resistor on it, and as he twiddles the knob, that data goes through the serial connection to the Second Life client, which then says, hey, by the way, I need you to move to 3 meters altitude. And the object then moves. So that's one way to get data fairly rapidly in and out of the Second Life world from your own software environment or from an actual hardware environment, because he was reading from a physical device in that case. So he was reading an analog input from the variable resistor. Now, there are better ways to do that. One of the very first projects that sprang up after Second Life really started taking off was a project called Libre Second Life. And this was a project to reverse engineer the Second Life protocol. So this started before the client itself was open sourced. And as you can imagine, with pretty much any proprietary protocol, there's going to be someone sitting there on the wire watching the bits flying around and saying, hey, I can do that. So a project started called Libre Second Life, which was an attempt to create an open source re-implementation of the client communications protocol. And that's actually been quite successful. It's worked very well, and it's got the unofficial blessing of Linden Labs, who are the developers of Second Life. And what Libre Second Life allows you to do is write your own software that pretends to be a client. It implements all of the usual client-side events. So it allows you to do things like log into the grid, passing your username and password, and then get data back from it. The thing is that it doesn't have all of the overheads of the usual client. Obviously, it doesn't have to do any 3D rendering if you don't want to. And so there are some example clients around, which are, most of the clients are written in C#, but you can also do development. There are bindings, I think, for some other things like Python. There are some example clients around that are actually really cool. In only a few lines of code, they let you do things like log into the Second Life environment and then send chat messages and receive chat messages. And it means you can do it off the command line in a very, very fast and resource-efficient way. Much more efficient than running a whole full-blown 3D client on your computer and then passing data in and out of it. So if Matt was doing it again, he would probably actually be using Libre Second Life, but at the time he modified the official Second Life client. That was the most expeditious way at the time. Another thing you could do is run a private Second Life sim. Now, at the moment, this isn't practical. The actual sim itself that represents the world is obviously the ideal way to get lots of data in and out really fast. The thing is that at the moment, the server itself has not been open sourced, although it's about to be. But there are open source re-implementations of it. So you can actually run your own sim. The problem is, when you start looking at something like a very big shared virtual reality environment, there are a lot of meta management issues that you have to take into consideration. For example, if you need to introduce a whole lot of things like the concept of physical space, which don't matter on the web. I mean, you go from one URL to another URL, who cares where the sites actually are located? If you have a sim, it has to fit into a master worldview somewhere. There has to be a definition of the grid, and then what sim fits into each of those little slots within the grid. And at the moment, it's impossible to link an unofficial sim into the Second Life grid. It's just, you can't do it. At the moment, Linden Labs is looking at how they can do that, and in the future it probably will be possible, but right now you can't. Okay, another thing you can do is HTTP out of Second Life. This is something that sounds pretty trivial, but it actually opens up a whole lot of really interesting possibilities. From any object within Second Life, which is running a script, you can open arbitrary HTTP connections to remote machines, which is really cool, because that remote machine could be under your control, and it could take control of things in the real world. So let's have a look at that. That sounds cool. All right, let's go back to this Arduino code that we were looking at just before. Now, in this particular case, what we've got is code that communicates via the serial port or the USB port, and it looks for certain values coming in and then controls outputs based on the values that you send it. So it's really simple code. All it does is go into a little loop, watches the serial port. If it gets a value of 1, then it sends an output, a certain output high, waits half a second, and then turns it low again. If it gets a value of 2, puts another output high, waits half a second, and puts it low again. And what that means is that if we can connect a couple of relays to those outputs, it makes it trivial to have software control over buttons attached to some physical device. So let's have a go at playing around with that. What I have here, and it's deliberately very low tech just to show how easy this is a couple of relays, each of which is connected to a transistor, a resistor, and a diode, and that's it. Really easy. So what we can do is connect that up to the Arduino board so that we can then turn those relays on and off. So all I'll do is connect up ground, and then we've got a couple of outputs. So in that particular case, what I'm doing is connecting to outputs, output pins 11 and 12. And as you can see in the code, they, well, actually you can't there because it scrolled off the screen. Somewhere up there. So we've defined the two outputs as being pins 11 and 12. So we can just address them as output 1 and output 2 to control those relays. Now, this little exercise here is really going to illustrate another aspect of this, which is that a lot of the times that you start hacking hardware, you end up linking things together into a long chain of objects. You end up with a physical device connected to another physical device, which is being run by the Arduino code, which is talking through a serial connection, which is being exposed to a network socket, which is talking to some scripting language, which is talking to a web server, which is then being triggered in this case by LSL, which is running inside Second Life. So we've got this long chain of events. But each link in the chain itself is actually quite small and simple. And once you start coming to terms with some of these little building blocks, you can link them together in totally different ways. So this is just one example of how to take that chain from the virtual environment all the way through to the actual physical world. So this is the program which is actually running on the Arduino right now. So we don't need to do anything much else about that, but I'll get rid of the RFID reader that we don't need anymore and plug in the USB cable so that we can get the Arduino back up and running again. Now, what we'll do in this particular case is we want to control a physical device. Once you start dealing with mains level voltages, that's when you get into the big scary warning labels and things that can kill you. This is a really simple way to play around with controlling appliances without zapping yourself. Basically, it's an appliance remote control. It's a little box that you plug into a PowerPoint, plug a device into it, and there's an RF remote, just like a car alarm remote control, and you can control appliances. Now, I bought this one up in Portland because obviously anything I buy at home is 240 volt. This is 110, which reminds me, when I went looking for a hardware store to buy this from, I discovered there was a hardware store in Portland called Chone. I thought, I've got to hack on hardware from a hardware store called Chone. It's too good to pass up. So this is exactly how it comes from the factory. You plug it in, you've got a remote control, but of course we don't want to leave anything factory. So let's start playing around with this. Actually, what it could do, we'll use that lamp over there. So could I get you to plug that into the wall and then plug the lamp into it? And there is no way this is going to stay the way it came from the factory. So what we have here is the stripped naked remote control. I'll pull the battery out of it for a minute. And it's just got 2 buttons on it. So all we have to do is wire the relays connected to this Arduino across those 2 buttons. Luckily, I happen to have a soldering iron right here. So these are the outputs from the relays. Now I've got to figure out which button is off and which one is on. So that one is on. Sorry if this isn't very exciting to watch, but it's a bit hard to see. Yeah, that'd make it exciting to watch. I should have got someone from the audience up to do this for me. It's not a very good soldering iron, but that's what you get for $6. Okay, so we've now got two relays wired across that remote control, connected to an Arduino. And we better power up the remote control. And provide some power for the relays. But we're a long way from done yet. So from within the Arduino scripting environment, we now have control over that piece of hardware. But let's have a look at the next step in the chain. So we need to talk to the Arduino and send it a value to tell it which relay to trigger. Now what we'll do is use a little script running on my local machine. So actually I'm not going to edit it. That's what being on the same desktop as a 3D renderer does to you. Okay, so this is just a tiny little chunk of PHP. All it does is receive a variable called command, and then it can either have a value of 1 or 2. And that tells it basically which button we want to press. Do we want to press button 1 or button 2? It then talks through the serial connection, once again using SIA to net, so it's a network socket connection, and sends that value to the Arduino, which is running that piece of code we were just looking at before, looking for a value of either 1 or 2. Very simple. And I better plug the Arduino into the serial connection again and power it up. Okay. Now the next step in the chain. This is running within Apache on my local laptop, obviously. Now I don't work at Google. I've just walked in here today and I'm on the guest network. Obviously I don't have an external public IP address. So what I've done is actually run reverse port forwarding. How many people have heard of reverse port forwarding? A couple, okay. So most of you are probably familiar with normal port forwarding or local port forwarding, which allows you to take a port on your computer and expose it and basically tunnel through to some remote machine. When you do SSH-L, the reason that it's at -L for the port forwarding flag is that it's actually local port forwarding. If you do SSH-R, it's remote port forwarding. So what I've actually done is done SSH-R and then opened a tunnel from a machine back in Melbourne, which is my desktop machine back in Melbourne, back through to my laptop. So right now, if we do a query, like do an HTTP connection to my desktop back in Melbourne on port 8080, it comes through to Apache on my local machine here. So what we can do now is go back into Second Life and wake up my sleepy little avatar. Oh, let's get rid of that door. We don't need that now. No, I didn't want that. Yes, okay, I'm ambidextrous and triple jointed. And instead what we'll do is create another couple of objects. Let's create some buttons. Now, I'm no good at building stuff inside Second Life, so everything I make tends to, I don't want that. Everything I make tends to look like a box. So we'll do create. Let's make our buttons round. We'll make little spheres. And we'll call this one on button. Very imaginative. And we'll add a script to it. Now in this particular case, what we want to do is, when this button is touched, we want it to open an HTTP connection back to the web server and talk to the Arduino and so on down the chain. So let's grab the code for that. It should be around here somewhere. So in this case, we've got a little object which, when it's resed, is going to say, hello, I'm an on button. And when it's clicked, it is going to, well, actually, we don't want string action 11, we want 1. It is going to make a connection back to my machine in Melbourne and pass it command 1. So the same as if we press button 1. So let's get out of there. And just for the fun of it, let's make another button. And we'll call this one off button. We'll give it a script. And the off button, if I've got everything correct here, is the second button. So we're going to send an event of 2 instead, and we're going to have the object say, hey, I'm an off button. So we'll save that. And now, this is where I look stupid if it doesn't work. So let's try clicking the on button and we'll see what happens. It says on button 1. Did anything happen? No. That's a good question. Yeah, the actual lamp itself, but I was just thinking what I'll do is I'll test. Ah, yes, that is turned on. Okay, so let's do some debugging back up the chain. Where is my browser? So I'll try bypassing Second Life and we'll work directly from there. No, okay, so the problem is not within Second Life. The problem must be further down the chain than that. Ah, I'm not getting a connection. I wonder if my tunnel has dropped out. Yes, that's what it was. So we'll open the reverse port forwarding again. Hey, we're back. Okay. And now we'll try this once again. Click the on button. Nope, still not liking me. Just in case I got them back to front. We'll try it from here instead of going through Second Life. Once again, I'm not getting a connection through. Let's just try localhost instead and see if I've got Apache working properly. Okay, so Apache's working properly there. I think the problem seems to be with the external connection. I can't get back into my computer from outside. So from here we can hit 1 to turn it on, and we can hit 2 to turn it off. But it doesn't seem to work if I go out through the external address. Oh well, you get the general concept anyway. It seems I'm being blocked by something along the way. But the idea is that from within Second Life, by clicking on one of those objects, we can then control the actual physical device and turn it on or off. So what I've shown you is a few specific techniques, but mostly it's little building blocks, little things that you can use to link things together, but from the software realm to the physical realm. So there are 3 things that I want you to get out of this whole session. The first is free your mind. Stop thinking about the world as being the way it is. The world is like a big Lego set, and you can modify it, you can tinker with it and connect things together. The second is hardware is malleable. You can take an object which is designed to do one thing and make it do something different, and modify it to suit your purposes. And finally, use scripts as glue. Think about how you can link things together to get from within the software environment to the physical world and vice versa. And I'm hoping that some of you will have a lot more imagination than I do and come up with other ways that you can use some of these techniques. So what I've done is created a There's a basic website up now called secondlifeintegration.com. There is also a Google group called Second Life Integration, and in Second Life itself, there is a group called Second Life Integration. And there is, up on the website, there is a bunch of source code, example scripts for some of the things that I've demoed today. And what I'm going to be doing is adding circuit diagrams and a whole lot of other things, but what I really want is input from other people that are playing around with this stuff. So if you've got any ideas, or if you've got little projects, things that you want to hack on, please come along and check out Second Life Integration and submit anything that you may have that could be added to it. And also these slides will be up as well for those that want to refer to it. So if you've got any suggestions or ideas, I'd love to hear from you afterwards. But thank you.